is using Kotlin. Okay, yeah, quite a number of people. Thank you. All right, so I'll give a small introduction to what Kotlin is because there is like half of the room who was not waving their hand. And there's a statically typed programming language which is done for multi-platform programming. So what it means, like the compiler is here to help you to make sure that the program is more or less correct. And if you do some refactoring, for example, the chances are if you do something wrong, the compiler will point you to the error where you like having a missing symbol or something instead of failing it with the runtime languages at the runtime. And it's really tough, could be, for runtime languages. From the other side, this is their multi-platform language, so you can target many platforms. And I have this slide like for several times for some time, and here it says like now official on Android. Actually, it was like 2 years ago, Google announced that the Kotlin is supported for Android development. This year, they have this update, so if you're doing Android now, it's recommended not only by JetBrains, not only by the Kotlin community, but also for Google and the Android ecosystem to start new things in Android, and they start saying that the new APIs will be first released for Kotlin, not for Java. So it's something you would like to try, but from the other side, you can build not only Android applications with Kotlin. Kotlin is just a generic language for programming, the same as like every of other languages in the ecosystem. So you can do the JVM, so like server-side, for example. There are many examples for people doing server-side apps. Android, I mentioned this one, the browser, like the JavaScript or Node.js, it is possible to be done, and you can interop with, say, TypeScript for type definition, so you can actually do the type-safe JavaScript programming here. And lastly, there is a native, so with a Kotlin, you can create a native app which runs on, say, iOS or every desktop. This app will not require you to have any runtime like JVM or Node.js, it will just run. And so there are plenty of their possibilities which you can have with Kotlin, and the expressiveness of the APIs, which we'll be talking about today, it is all applicable for every target you have, so it's independent from the target. So let's speak about the expressiveness of the APIs. And there are several points which we can have here. Like, for example, this one. This is not only the title of the talk. From the other side, this is a valid program in Kotlin. So if you would like to know how to implement this one, just ask me. I'll explain or give you a code snippet showing this. This is a way you express the syntax of a language is done in a way you can have more abilities to create more interesting things. I'm not trying to say this is the best thing what you can come up with. No, necessarily not. I'm saying it is possible, and then it's you to decide which is the best thing you would like to have, or how would you like to do. Some others say there is a DSL. But if you take a look on this, it's really connected to the expressiveness. So our domain-specific languages, this could be the things like, well, for example, if you open the Wikipedia, you'll find really interesting information saying, okay, domain-specific languages are languages specific for given domains. Fine. What it means that you can express what you need for a given domain more easily, more naturally for that domain. So you'll probably be able to speak with experts from that domain, like say accountancy or business rules or anything like that, like in a way they like to speak with you, instead of using the general purpose language where you say, okay, here is my function, here is a create new object, and there now people, are you able to read this? Well, sometimes they are, sometimes they are not. And we have DSLs along our development for many, many years. And one of the examples is the SQL. Are you writing SQL? I guess no. SQL is still alive. Figurable expressions. I will not ask you because I assume that everyone will at least try it once. And there are many, many other examples where we have specific languages included into the other languages. But let's put it the other way. If you, for example, for some reason see that there is a need for a domain-specific language, and you would like to start from scratch, how would you do it? Well, you need to learn something about the parsing, lexing, years recovery, and then you realize that there's a huge stack of things to be implemented, and at some point you come to your colleagues saying, fine, guys, I have the cool solution, I have the APIs, I have the language, let us use it. And they will come to you, they reply you saying, wow, cool language, yeah. Do you have an IDE? Or do you have a CI support? How do you run tests? And there are so many questions which can be tricky to answer if you are trying to build a like DSL from scratch. And here comes yet another way. Instead of recreating the whole ecosystem, you can try using the existing tools like Java language or your project language and build the expressive APIs on top of this layer. And the benefit here is that this is our only APIs, so technically you don't need to agree with someone on something. You can say, I just want to use these APIs. And if they like these APIs, that's it. You don't need to reinvent the IDE. You don't need to reinvent their CI support. You don't need to reinvent testing and all the pipeline. It is here for you. And here comes, of course, this is nothing new here. And here comes the server IDEs like the Java style builders or Fluid APIs, depending on where you see it. And here comes an example for it, like this. Say, what do? You say, OK, I need to define a graph for, in this case, it is the code for unit tests. So you need to define a graph. Say, OK, this is a graph. I would like to run my application on this graph and see some properties on it. And this is, as you see here, this is a reg function at the very, very beginning, which does the whole thing. But I want to tell you, this is a bad example. And please don't do this. And here comes the answer. The problem of this and the lack of the expressiveness here is that you have the command. Actually, I have a command here, and I have the code. And how do you think, will it be the same in the 5 years? It could be the case that someone would like to fix something in this test or this program, and they'll just update their code or comment, but not them together. So when you be the next one to fix this test, what you may find out that the picture is not correct after several hours of debugs. Not the best thing which can happen. That's why if you can express what you need without having the comment, this is a good way to go. Here it comes yet another example, like from a C#, like you express something with the Fluent APIs. Or I found out yet another one at the JVM, which does the RTF formatting. These are more or less good examples. You can barely understand what they mean, and you don't need to comment this code to explain what you're actually intending to say here. And these are more or less good. Here comes yet another example, and I don't know how you feel about the YAML, but if you would like to create a YAML, I would like to use something with a compiler to make sure that it will help me to author the correct file without any problems in this, with the escapings or whichever could be along this way. So on the left side, you see a tiny DSL, which defines the Kubernetes config. From the right side, you see the thing which is generated. So you can, if you would like to simplify the process, or if you would like to, for example, do testing on this, you can you can use another language to generate the configs, and then you have an API model, and you can run tests if you like. Here comes another example. I hope you will not find the basic language or the best language to negotiate with someone, but let's assume that you have the business rules written many, many years ago, and this is the way you can communicate with others. Well, it could be. And by the way, this is a valid Kotlin program, so well, it's not that complicated to implement this one. And so as for DSLs or expressive APIs, I try to say that these should be the APIs which are easy to read, where you can easily express what you want, and these are APIs which you can share with someone, and they should be able to understand what you're trying to say. This is what we can try to achieve, and this is what should be possible to be achieved. And this is applicable for many, many domains, like the configuration files. It could be the business rules. It could be the user interfaces, or like every place where you're trying to make your code a little bit more nicer. It could be applicable. But nicer means your feeling. Nicer doesn't have any good definition. And here comes yet another example. Like, say you have an HTML, and well, we need to return this HTML from a client side, from a server side. It depends. But we actually like to have something like this behind. Well, I don't know how many of you remember the GSP. If you ever try to see what the code is generated underneath the GSP, you'll see something like this. And in reality, what you will have many parameters being mixed in this thingy, to deliver the actual response to a given user with a given context. And it is hard to support, but we can change it. we can jump from this one into the things like this, for example. The fact is that I hope you are able to understand what it means. It looks pretty comparable, but this is a program in the language with a compiler, so the compiler will be able to say if you're doing it right way, if you're doing it the wrong way, and the compiler will help you to see the error. From the other side, the IDE will be able to help you to say what is possible, what is not possible at a given context. It is now available, and the tooling and the whole tooling are here to help you. So for example, if you're dealing with HTML, the tooling can help you seeing the errors, but it's your activity to find this and fix it. Here, the compiler will say, there is no way around, you have to fix it. From the other side, this is the way where you can no longer fail at the XML layout or HTML layout, at least, because the closing of tags are taken care of by the blocks. And why Kotlin here? It turns out that Kotlin has a statically typed language, so it helps to deal with these complex things, and you understand what you're seeing at the given context everywhere in this example. And from the other side, the syntax of the language is done in a way where such things are possible, and sometimes they help to minimize their efforts you need to write something in the programs. And then lastly, IDE with the code completion, with the error highlighting, the compiler with the errors. These are all here to help you to understand and fix the problems. And lastly, all things are available for many platforms. It is not only JVM. It could be Android, it could be JavaScript, it could be native. So it's up to you which platform you would pick for selecting this one. And from the other side, the Kotlin is concise. So you tend to write less, and you'll see it a little bit later. It is safe. In Kotlin, you tell the nullable variables from not nullable variables. So if you start using it, it will be helpful. There is interop, by the way, so it's 100% interoperable with Java, which means that you can mix together the Kotlin sources with your Expressive APIs or DSLs or anything with Java sources of the existing project, which can run even with Java 1.6. Are you, by the way, up there? Who is using Java 11 by this time? Or more than 11? So this is something which may help you. So if you are still with the older Java, you can use the newer language and you don't need to upgrade. The multi-platforms, which is possible here, means that you can build the whole stack, like the client side, the mobile side, the website. Anything could be done with the same language, even the build scripts. Like Gradle supports Kotlin Gradle DSL, which means you can define your build configurations on the build projects using the Kotlin DSL. And it means like you can see what is going on with your Gradle scripts by just navigating to the declarations. It will supposedly work. The Kotlin by itself is open source, and the last year we had release 1.3. So if you're using Kotlin, just make sure you use the actual version. It is backward compatible for JVM, so if you're using it for JVM, it should not be complicated to upgrade. Just changing the version in the plugin, and it's supposed to be done. This is a good link, but please don't use this link while I'm here. I can help you with the questions. When you don't see me, this link will help. And if you Google for some question, probably it's a good idea to pick the link to this website, because you're likely to find the answer in the documentation website of the Kotlin language. And I really like this one. The idea is that if you start learning the language, it is a good idea to have the hands-on, to try solving some real examples, like Kotlin coins, which are available at play.kotlinlang.org. Or you can open an IDE and you can just start hacking and coding something with Kotlin, or any language you would like to learn. It will help you to improve way faster, and you'll understand more than by reading something. And what I'm gonna do, I'm gonna switch to an IDE, and I'm gonna show you some example of the Expressive APIs. So are you able to read this? Is it fine? Okay. So if it is not fine, you can move closer here. You have plenty of free spaces on the left and on the right, so please don't hesitate. And actually, this is a Kotlin program. This is a main function, and you can start it like here. What we do, here I have the Java APIs. So I have like a module of several Java classes. Like, let's assume we are working from, say, a database or some other layer where we have the POJOs. So I have a client which is an ordinary Java class. It's fine, it doesn't fit the screen here. It has so many information over here. What we need to know about it is that it has name, it has the company, and it has a Twitter account, which both are there yet another small classes like that one, or the company name, and the yet another one, which is just a wrapper for. So this is an immutable model, and along with this we have a builder. So we have a Java client builder to build the Java client. We have a Java company builder. We have a Java Twitter builder. And this is the kind of, I hope this is kind of a standard APIs we have all the time to deal with any data. And so the idea is we will be using this API from Kotlin, and we will not be changing these APIs in Java APIs, rather than we will create the wrappers in Kotlin to solve it. So, and here has an example. What I do here, I try to create an object. And let us turn this one into Kotlin first. So I select this Java code, and I jump back into the main.kt, and I simply paste it over here. So the first thing which you're likely to see if you turn in Java into Kotlin is that the IDE will tend to try to help you. And so what it does, I say yes, it just converts the Java code snippet into a Kotlin code snippet. So now I'm done Kotlin. So this is the way you may start if you do hands-on. And there are several things which you may notice here. The first one, I think, is that to declare method or function, you use the fun keyword and the method name. And the return type comes on the right if you have some. If there is the void return type, you can omit this one. And this is how you create a class. There is no new keyword. There is no semicolon at the end, but well, you're free to use it. As long as it is not a Greek character. There is a semicolon-looking thingy in the Greek alphabet. So the second thing here comes that in Kotlin there is a concept of the bean, Java beans notation. So if you have a getter and a setter, instead of calling the get something or set something, you can simply use it as if it is a field. It is called a property, like this one or that one. So behind the scenes, it goes and it calls the set first name from Java, but it reads a little bit nicer. So but technically, you may still try to say something like set first name and something. It is also possible, but the code compilation will not show you this option. And from the other side, there is a highlighting. I don't see if you see the highlighting underneath. It tells us that there is a better syntax to use it like this. But okay, let us see what we can do here. This is an example, and let us try to build something like the utility function. Because when I build an object, what I need, actually I need, given a builder, I can fill this up, right? So the fact that I mix here the knowledge how to find the builder classes and the knowledge how to build them is something extra. We can remove this one. How would we do with this? Let's create a function which is called build client, which takes an action, like the builder action, which is I think the consumer or supplier. Let me try. Supplier from Java client builder. So we have an action like in Java, right? Let's see what supplier means. All the time I can tell it should be consumer. So you see the supplier has the only method to return something, but we need a consumer to consume something. So it should be consumer, like this one. And now we do the building. So we take the builder here. Then we say the action just apply, accept builder. And then we say return builder build. And we need to declare the return type of this function. So this is how, by the way, this is how you declare the parameter in Kotlin. The parameter name comes on the left. The type is on the right. All the places where you specify type in Kotlin, it's all the time on the right. So here it is on the right as well. Now you have a build client. And now we can update this program into the following one. So we say build client, or we actually say the client. So is a build client, and here we create an object. And this is a way how you create an anonymous object in Kotlin. And you implement this one here. I call this one builder. And I simply move the whole thing over here. So the change is that we no longer need to know how to build the whole client. Instead, we simply say, OK, I know how to fill the client, and I'm here to fill it. Give me the builder, and I'll fill it. Well, this is maybe a little bit more tricky pattern, but if you probably deal something with their databases, you may remember an example like this, like saying, if you do something with database, you're likely to have a utility, like that one, like run with connection, saying, OK, here's the operation I would like to do under connection or under transaction, under like something similar. And why you do so? Because it's so nice that you can control the way how you allocate the connection, transaction, whichever, and how you dispose it. So you no longer need to return this pattern all over the place in your code base. It is so easy to break it, and every issue here will be the problem in the production, because if you're leaking the connections, you're likely to be not way too long in a running state, because the connection will run out or something else may happen. So this is an idea, and now let us see if it works. So I would try running this out and see how it flies. Oh, it works. Oh, I really like this. Do you like this one? It's a pleasure debugging a program when you see such a two-string things. And as I stated before, we have no rule. So by the rules, we cannot change the Java code to fix it, to implement the two-string on their side. What we do, let us create a function which is called Java client, R2 debug string, which is our user. I'll explain a little bit of the magic here in a second. So now I would say here R2 debug string. So the first thing, this is called the string template. So you may use $, and in brackets you can specify an expression. Instead of using the plus and there is several strings concatenation, it is just a shorter way to play it. And the second thing, you see here, I've just created a method for a class. But it is not true. It is only a syntactic sugar. So in a Kotlin, you may say something like this. You say the type on the left and the method on the right. It is extension function. You may know something about this from like C# and other languages. The idea is that the language allows you to use it this way, and this is a way to get rid of like kind of a utility classes which we may have. Like in an older way, in days I remember myself, we had like the utility for dealing with strings, utility for dealing with some object from another side of our APIs, and yet another utility to deal with the first utility, and so on. Instead of having this, you can create extension functions, and they live in the package where you declare them. So depending on what you import, you see the different extension functions. So it's OK to have the to-debug string in this package, and the other team may have yet another to-debug string in their package, and it will not collide. But of course, if there is a real method in a type of the same name, of course it will win. But in this case, there is no debug string in the original class in Java, which is from Java. And now we can start this one again, and we'll see that, oh, now we have some meaningful information being printed. And along the way, it is still working. So, but now let's make it a little bit more nicer what we have here. As you see here, we create an anonymous object, and it's kind of a long thing to create. Is it like 1, 2? It's almost 3 lines we need to spend on this. And here comes yet another way to solve it. Instead of calling this interface from Java, what we can do, we can declare the Lambda function in Kotlin. In Kotlin, you can declare Lambda functions in a standard way. So they are the language citizens like all the types. So you may say that you're doing something like this. So this one means that you say, I have an action, which is a Lambda function, which takes one parameter of type Java client builder. And after an error comes the result. Result is unit. It is the same as a void. It's just called unit here. And if you have more parameters, you can simply include more parameters here in the way you like it. Or, of course, it could be 0 parameters. Why don't you have a function from 0 parameters? It's the best functions. And it is a function, so you call it like in a way like it is a function, like this one, right? And at that point, we need to fix the code which we have here. So instead of writing the whole thing, I simply say it this way. So this is how you declare the lambda in Kotlin. So you say it this way. So you use the brackets and use the variable name or variable names and the arrow to specify the body of this lambda. And if there is no variables, you can just drop this out, and this is a lambda without any parameters. And in Kotlin, there are several things which helps you to simplify it. And the first one is, if you have a lambda with one parameter, like we have, you can name this parameter as it. And as long as it is named as it, you see the highlighting. Like it says, OK, you can drop this out. It makes it a little bit shorter. It makes it a little bit less noisy. And now it reads a little bit better. The next thing is, if you have a function, and the last parameter of this function is a lambda, you can move it outside of the parentheses. So you see here parentheses, and you see here the intent from IntelliJ saying it's a good idea to fix it, so I'll fix it this way. So now I don't have parentheses here. It looks now like this is an embedded feature of the language, but it's not. It's just a function, which has a lambda as a parameter. If I have more parameters, of course, I can have it here in this way. Fine. What else? It looks a little bit better so far, but not the best. What I would like to have, I would like to get rid of these its, because this gives me no information so far. It is like the garbage which I have to have here. And this is possible again. And let's see the interesting thing here. Let me move it here so you see it. So the first line is the extension method, right? We've created an extension method to deal with to create a helper method for us, right? And the second line here, an action. Action is the lambda, right? And if I have a lambda for just a function, we may have a lambda which is an extension function. Looks crazy. If I had it, I would call it like it is a member of this builder type. So I would like to say it something like this. And it is possible. What do? You say, you just declare the same way as you see it above. Like, you use this. It's kind of a tricky thing. Inside this lambda, this keyword will refer to the Java client builder. So it actually means that the example which we have here, it's now working. So when I say here the first name, it is exactly the same as saying this dot first name or this dot last name. And this one jumps into, as you see it from the code completion, it jumps to, actually you don't see it here. It goes to the Java client builder, the same Java client builder as it used to be before. But now you don't need to clearly say it. It is included into the context. By saying this one, it is enough. And it makes us to the next step towards the shortness, so we can say it like this. And we can say it like that. Not bad, is it? But still we have several games here, this and that one, and we need to get rid of this as well. What we do, I create a function which is an extension function for Java client builder, which is called Twitter, which takes an action to build the Twitter. So it is a Java Twitter builder. So again, I use extension function lambda here to make this happen. And here I say something like, so I create a builder, which is a Java Twitter builder. I say builder action. And then I say that Twitter equal to builder build. So the magic is that this function is an extension function for Java client builder. So this Twitter is the same as that Twitter, as the same as the set Twitter or Java client builder, right? This is an action to fill up the Twitter pojo. And so I create the builder. Now I know how to create the builder. No one else knows. And I give this builder to them to set this up, to fill the fields. And then I build it, and I assign it back to the here. So I can call it this way. I can call it not that way. I can simply call it this way, so I no longer need the whole thing here. And I can simply use that one over here. Tricky, isn't it? So that Twitter is their extension function, which is declared here. It takes a lambda, which has their Twitter builder as the receiver. That's why the handle works. So the handle is their setter from Java Twitter builder, which is declared in Java. So you can go here. You can navigate over here and see it. It is here. It is still here. So we combine together several tricks to shrink their whole program. And they similarly, you can build the company. What I can do, I can say company equal to, I can use the standard functions from their Java, or from the Kotlin standard library, and I can do apply. This is a standard function which does actually nothing, but helps me to deal with with this magic. So what I do here, I do it something like this. So if you're given a task, an assignment to fill this up, to create a nice looking DSL, or just to create a huge big object, you can follow this pattern. The apply function comes from the standard library, so you don't need to create your own one. And its implementation is really straightforward. What it does, it says, okay, I'm an extension function for every type. What I do, I call the block, which is a lambda with a receiver for this type, and I return the incoming type back to you. So if you have something to run within the context of an object, just use this one. And it gives us the following power. We can shrink the solution to that short thing. Now, let's complete the example. So I need to create yet another function for their client. Let me cut it. Let me create this one. So it will be client. And we'll take Java company builder. It should be called company. And I will implement this one the following way. I will say, I'll just take this whole thing away. From here, I put it here. And the apply is a function. So you can pass the lambda to a function, or you can pass another variable of specific type to this function. So you can do it this way as well. So actually, the implementation of the Twitter and the implementation of the company, they are the same. There's no difference here. And now I can say company, and I can simply drop this out. And that is it. Let me start this one. Seems working. So let me show what we have, what we started from, and what the result we have in here. So this is what we started from. I put it on the right top, and this is what we are having here. Let me open this up. This is what we are having here. So speaking about the expressiveness of the APIs, so we started from this API. Of course, you can share the right side with anyone, and they spend like 5–10 minutes reading this to understand what you're trying to say. Fine, they can compile Java in Mind. Everyone can. And mindful debugging is the next step, but it's a different topic. But from the other side, the left picture says, OK, you can do exactly the same, definitely exactly the same. It will even generate exactly similar bytecode at the lower level. But you can write it a little bit more human-friendly way. And this one on the left, you can bring to someone who is quite far from your programming, your Kotlin, your Java, your JVM, web services, anything, and they still are able to understand this. Now imagine this is your a business rules for your application, or a part of your unit test or integration test which you're trying to create. Well, this is something interesting, is it? So we're going to jump back into the presentation to see something more fancy thing. So this is the URL. So if you're looking for more help, ask me. If you don't see me, use this URL. There are several links in the presentation. I'll share the presentation later on today, and there you might have clicked on these links. That's a good thing to you might Google it, like extension functions, types of builders. The types of builders is a good example of what we've done so far, and it has more explanation on their topic. And the next thing is that remember this example, right? Now you see it again. Does it feel any better? Well, I tried to make it feel a little bit better. So probably you see that here the HTML is a function which takes a lambda as a parameter, And their head is like yet another function, and their body is yet another function. And these all Lambda functions are likely to have a receiver of some type to make this happening. And by the way, that's a question for you. Why do I have the plus here? Well, think about it. And the example above is from the Kotlin X HTML library. So this library available on GitHub, you might take a look and use it. And they're turning back to this plus. The plus here is because you need to attach the string into the building HTML. And you can either use the reloaded operator like the plus symbol here, or you create a function like add line, add text to add text to the HTML you're creating. If you remove the plus symbol, this will be just a string, which is nothing to be done. It's just the constant, which means nothing, and it will not be included into the HTML which you're trying to generate. And there yet another links are, I think I've shown you the similar slide before, but are the types of builders. It's the hint for understanding the HTML example if you don't see how it works exactly. And operator overloading in Kotlin, you can overload the operators like the standard operators like you expect in ARC-like languages. They can be reloaded. And there it comes to, let's speak about yet another thingy. Here it's, I called it guarded by. And let's consider an example. We write in a program with a mutable state. Well, a horrible thing to begin with, right? And we have something like this. Have you seen this code before somewhere? Like, not particularly that one, but the idea is like you have a lock or some kind of a locking within your class, and you have several fields which you expect to be protected with this lock. And technically, you have no way to enforce it. There is no way. You can only hope that it is so. Or you can think, OK, I will check this code. Every time someone will change it, I will make sure that it is done. Or you may use some linters or the annotations, and there is some code analysis to enforce this check. It is tough. It is hard. And from the other side, it is concurrency, so it is not so easy to test. What can we do about it? Can't we do it a little bit more expressive, and a little bit more concise to make it not be so easy to break? And the answer is, well, we could. We can. And this is the provenance I mentioned here. So the first step could be, let us extract the state into a small class. This is how you declare a class with two fields, which actually this is two pairs of getters and setters here. And as long as you extract this as a class, you can create yet another class, and you can use this invoke function. This is similar to what we've done with the lambdas with the receivers again. So the idea is we make sure that you have to call the specific function to get access to this state, where t in this slide is the state object which was here. So we can do it, and we can enforce the safe access. So no one can go around this. The only way to access this state variable is to go through the invoke function. And we can encapsulate the locking inside this invoke function. You see the idea? So this would be not possible anymore. Like, assume I have the guarded and then invoke. So I cannot access the shutdown field outside, but I can access it inside. And their downside is quite slow. So it is only a few lines to write. And we can go further and say, I can create the operator invoke. Probably this is the only exception to the set of operators which you can create in Kotlin, comparing from C-like languages. And if you create an operator invoke, you can turn it into something like this. So having the guarded a specific class, you can say, OK, if I would like to access something which it guards, the only way to do it is to write this code. So it is like one line to make sure you do the locking in the right way. And there is no way to do it there is no other way to solve it. So it means that everyone will likely to follow this way to write the program in the best possible way. Isn't that good? So to demonstrate this a little bit more in detail, I created yet another example. It is here. I decided to model the meetup conference. So what we have here, it is here. So what we have here, we have the meetup room, and it's an example of object where you try to say, I would like to synchronize. So it's written in the standard way. What I have here, I have the reentrant block, and I have several methods to do some operations, right? The first thing which you can simplify in Kotlin, if you're not trying to reinvent this guarded thing, what you can do, you can turn it into this way. If you would like to have a lock, you can say with lock. This is a helper function to reduce this code. So if you're dealing with a reentrant lock, read-write lock, or other locks, the standard library comes with a with lock function, which is the trivial one. It does lock, it calls your action, it does unlock. That's it. But it is an extension function again, so you're not forced to change the standard like APIs which you have in JVM. It looks better now. It looks shorter now. Yeah, and by the way, I use the equal sign here to it's a shortcut. If the body of a function is an expression, you can use it. But if you would like to make it longer, you can specify the type, by the way, and you can convert it to a body. So this is a longer way to have the same thing. It is up to you how expressive you would like to be here. If you would like to be expressive, you can turn it out. You can turn it into the expression body, or you can. I think you should. You can simply say something like just say like equal and an expression. And this is an expression which takes a lambda as a parameter. That's why it looks almost like a method, but a little bit different, achieving this result. Similarly, we can fix this one. But it is not the full solution, because now, of course, I can create yet another method, like something like this, which would do something like people. And oh no, I forgot to do the locking in the right way here. It's not that thing. And how I fix it? What I do, I create a class which is our state, or you may call it like the meetup state. Meetup state. I move all these things inside this class, right? And I no longer need a private here. It's fine to use the state object. And I create yet another one which is called guard, which has the private state, which is meetup state. So I have a field with my state here, and I have an operator, a function invoke, which takes an action, which is the meetup state to t, and returning t, which is so this is how you declare, by the way, this is how you declare a generic function, which is simply say something like state.action, right? So now I can, and the lock comes over here, and what we do, we create our state this way, and we call it guard, right? And now you see here, now I broke anything. All the time you do your live demo, you broke anything, and it's the different case. I broke it by intent. And how to fix it? I simply say state. It looks crazy, right? I think it will look a little bit better. Is it? So here comes the convention. So if you have an invoke function declared on a type or as extension function, you can add this the magic word operator in the declaration. And it means that you can call it this way. So it is the same call to invoke function, but the compiler allows you to be a little bit more explicit here. And you can define a shorthand. And similarly, we can fix it here. So we can simply say state. And we'll fix this one by saying again, like I can put it in a longer way. I can say state here. And that is it. So now, if someone would decide to hack on the state, or they decide to create another method, there is no more way to make it happening but using this guard. Of course, you can implement the similar thing in other languages. Of course you can. But it will be way more longer. And you'll be unlikely to use it, because you have to generate the enormous line of code to solve it. But here is, by the way, you see here the interesting fact. Here I have yet another example. This is a method which returns something. And will it work if I say something like, you see here the problem. Here comes the problem. It tells me, you cannot return from a lambda. This is the right thing. Because if I would like to return from a lambda, I have to clearly say that I would like to return from a lambda by saying return at and their name, like the state in this case. Or I may even name it like something like this, and I would say return, and their, right? But now, brace for the tricky thing. There is a way in Kotlin to allow this return to work. So actually, for a specific case, you can say, I would like to return from the method, no matter you are in Lambda right now. Crazy, isn't it? Like, I would like to say this return has to return from the run the task. So if I ever had any statement like, let me turn it to the block again. Or if I ever had the example like this, so I turn it into block, I have this state thing here, and I would do something like logging here. The idea is that if you do the return with an annotation, like return from a Lambda, you will reach this point, that point. But if you use the right return, you will not. And to allow this to happen, you simply go here and say are inline. And if you say inline for a function, it will make the function be just copy-paste. The source of the implementation of this function will be copy-pasted to the place where you call it. As long as it is copy-pasted, the Lambda, which you pass it inside, is no longer Lambda, it is just a code. As long as it is just a code, you're allowed to do return. And it is broken because I was supposed to say that I'm returning a string here. Now it is possible. That's yet another trick which you can use. But if you're, there are many inline functions in the Kotlin standard library. So if you try to return, sometimes it may turn out that you can return, but it may do another effect than you expected it to. So if you see it, don't be super surprised about this. Just understand the difference here. Okay, let's jump back to the presentation. So actually, we've played this operator invoke, and it's kind of a powerful thing. You can use it to define some nice APIs you have. And they're like, again, this is a link. So if you would like to learn more about Kotlin or you have a problem, open this link. And I want to mention the Kotlin coins, especially this one. These are a set of small exercises. So if you would like to practice with Kotlin by solving a small assignments, this is a way to go. You can either do it on play.kotlinlang.org from the website, or you can install a plugin for your IDE, for IntelliJ or Android Studio, I think. And there you can play with this just by coding it from your favorite IDE. It's up to you how you would try it. And we have a Kotlin Slack, by the way. If you would like to speak with others, or just join this Slack. It's more than 20,000 people in there. Have you seen a Slack so big? This is an example. And oh yeah, that's the best topic here. What if you would like to create something new, like some expressive API? And how you do it? You try to use the syntax of the language or even abuse the syntax of the language to achieve your goals, right? And it is complicated sometimes. And sometimes you need to know something about the language and that deep that you may, it takes time to learn. Instead of doing so, you may try coding what you like. Then you click a button in the IDE saying, just generate me a function, property, extension property, or put your name here, put your entity here. And depending on the context, it will suggest you something different. You know the basics right now. You've seen the basics. And now you can build your own DSL by doing so. And it should, you create the definitions, and then you, the first step, make it be the syntactically correct at first. Then you add the semantics, the behavior inside. It is the second step. The first step to make it compiler be happy. And then you can have something like this. Again, it's a valid program. I hope you will not need it. But here, the backticks, it's a really interesting thing. The backticks allow you to name the methods with the white spaces, name the variables with the white spaces, or the array characters which are possible. The only limit is if you're targeting the JVM, the only limit is the Java bytecode specification, which allows you actually having the white spaces and the Unicode in the method names. I think you are not allowed to have a dot in the name, but besides that, you can do whichever you like. And I hope you will not need a lorem ipsum DSL, but if you would, well. And the second trick here, this is an infix function, or like ipsum here in the second line is an infix function. So the function which takes the first parameter from the left and the second parameter from the right. It is also possible. And Or yeah, you've seen this example before. It is possible and it even works. So it has a semantics comparable to basic language. And there are several moments, and I will explain a little bit about the existing DSLs. The first one is the DSL I've shown you to create the YAML configurations for Kubernetes. If you do many things with Kubernetes, you'd probably like to extract a function, like to create a common definition with the all defaults you would like to for your company, organization, or like application. Or you may deal with like it is yet another example. I was trying to create an XPath queries, which are the related language constructs and the delegated properties. If you're dealing with a TeamCity or the CI, it is really fun. You can create the definition of your jobs using the DSL approach. And then if you have a similar jobs, you extract the function, which creates the essential setup, and then just use it. Or the Spring. Our Spring 2.5 has so many features which don't fit this slide. And there is a BDD testing framework which you can do. There is the DSLs like this, so you can define the way how you test it in a BDD style. It is pretty readable. It is pretty following the BDD things. There is a Kotlin HTTP server which you can use, and it is there from one side. It has coroutines. From the other side, it actively uses the DSLs or the Expressive APIs where you define the routes, where you define the extensions, and all the things are like this, for example. And by the way, this was the HTML DSL we've shown before. And as for scripting with Kotlin, it is possible to use Gradle, or Kscript. With a Kscript, you can use the bash script-like alternative. And with the DSL for KDS, you use this one or that one. You can define your builds with Kotlin Gradle DSL, and their IDE and the compiler will be understanding what you're doing so far. Like this one again. And this is the link. In the JetBrains, we use Kotlin in many, many projects. And IntelliJ is a Java application. We mix Java and Kotlin together for all our IDEs and the web service. And I just like this slide of their pictures. All right, these are all our products, or some. I think it's something is missing here, but it's really hard to get which are missing. And you've seen something about Expressive APIs, so we've learned a little bit about the Kotlin features. Come by, ask me questions if you'd like to go deeper, and go and try this out. It is an amazing world here. Take a look what you will find out here, and let me know. I'm curious to know. Well, thank you.